Okay, so let's talk about the conic section that we call a hyperbola. It's a set of all points in a plane, the difference of whose distances from two fixed points, called foci, is a positive constant. And if you saw the ellipse screencast, you may have noticed that in an ellipse there's a set of all points, the sum of whose distances is a positive constant. Here, if I pick a random point, x comma y, and I'm going from the distance from one focus minus the distance to another focus, so d1 minus d2, that's going to be a constant no matter where I am on the hyperbola. Okay, so what does the equation of hyperbola look like? Well, the standard form looks like this: x squared over a squared minus y squared over b squared equals 1. Once again, it looks like like an ellipse equation, but we have a minus instead of a plus right there. Okay, now the actual hyperbola are these curves here, and every hyperbola has two of them, and they're called branches. They are not parabolas, okay? So those are called branches. Your foci are always inside the hyperbola. You have two of them. In this case, to locate them, c squared equals a squared plus b squared. Once again, with an ellipse, it was a squared minus b squared. Here, it's a squared plus b squared. Your vertices are these points right here, and you have a transverse axis. That's the axis that connects the foci. Your vertices are on that transverse axis, and the midpoint of the transverse axis is the center. So there's the center right there, and you have a focus here, F1 and F2. A hyperbola can have a vertical transverse axis like this right here, okay? And if that is the case, then you have your y squared term minus your x squared term. Okay, now, with an ellipse, remember that a squared was always greater than b squared, but with a hyperbola, that doesn't have to be true. A squared does not have to be greater than b squared. A squared is just the first term that's positive, and then you have the b squared term being subtracted from that. Okay, so if you have y squared minus x squared, it's going to be vertical. If you have x squared minus y squared, it's going to be horizontal. So how do we graph a hyperbola? Well, it's not that hard actually. Notice that here we've got x squared minus x squared over 9 minus y squared over 25 equals 1. Since x squared is being subtracted minus y squared, then we know it's going to be going horizontally. So a squared is 9. That means a is plus or minus 3. B squared is 25. That means b is plus or minus 5. Okay, so a is underneath x. So I'm going to go out 3 in the positive direction. I'm going to go out 3 in the negative direction. 25 is underneath y squared. I'm going to go up 5. I'm going to go down 5. And instead of drawing an ellipse, I'm going to draw a rectangle that contains those 4 points. Then I'm going to draw asymptotes that go through the corners of the rectangle and the center. And then I will do my hyperbola in green. I just make it fit in between those asymptotes. Okay, I knew it was going to be going horizontally because x squared is coming first. So here's one vertex right here. Here's another vertex right here. What about the foci? Well, c is plus or minus the square root of a squared plus b squared, which is plus or minus the square root of 34, which is just a little bit less than the square root of 36. So I am going to put one focus a little bit less than 6 here, and another focus a little bit less than 6 here. So we'll call that focus 1 and focus 2. Now in this example, we do not have an equation in standard form, so we've got to make it in standard form. So here we go. Let's group the x terms together, group the y terms together, and put everything else on the other side. Factor out a 9, leave a space, factor out a negative 16. So when I factor a negative 16 out of positive 32, I'm going to get a minus 2y, leave a space, equals 151. Okay, so let's complete the square. I'm going to take half of this and square it. So that's 1. I'm adding a 1 times 9, so I'm going to add a 9 over here. Take half of negative 2, square it, which is 1. And I'm adding a 1 times negative 16, so I'm going to add a negative 16 to the other side. Okay, so what does this work out to? 9 times x minus 1 squared minus 16 times y minus 1 squared, and 151 plus 9 minus 16 is 144. Okay, so standard form of an equation for hyperbola has it equal to 1. I'm going to divide everything by 144. 9 goes into 144 16 times. Isn't that convenient? 16 goes into 144 9 times. And it's equal to 1. Okay, so what's going on here? Well, instead of our center being at the origin, our center is at positive 1, positive 1. So I'm going to put, that's my new center, and I'm just going to move my axes over 1 and up 1, and then I'm going to graph the hyperbola like normal. Okay, so in the horizontal direction, I'm going to go 4, 1, 2, 3, 4, and 1, 2, 3, 4. In the vertical direction, I'm going to go 3, 1, 2, 3, 1, 2, 3. I'm measuring it from my new center right there. Okay, let's draw in the box that will determine how our asymptotes are going. And I'll draw the asymptotes in red. There's one. There's the other one. Okay, we have x squared minus y squared, so it's going to be, the hyperbola is going to be going horizontally, like that. And last thing, let's locate our foci. So that's going to be c squared equals 16 plus 9, which is 25. So c is plus or minus 5. So from my new center, I'm going to go out 1, 2, 3, 4, 5. There's 1. 1, 2, 3, 4, 5. There's the other. So our foci are at negative 4, comma 1, and 6, comma 1. And that's it. Okay, last example. What if I know that the vertices of my hyperbola are at 0, negative 3, and 0, 3, and the foci are at 0, negative 4, and 0, 4? Okay, let's do a quick sketch. 1, 2, 3. There's one vertex. 1, 2, 3. There's another vertex. There's a focus. There's another focus. So this hyperbola is doing this. And obviously the center is at 0, 0. So we are in the form of y squared over a squared minus x squared over b squared equals 1. How do I know that y squared comes first? Because the hyperbola is going vertically. Okay, well, the distance from the vertex to the center is a. In this case, that's 3. And the distance from the focus to the center is c. In this case, that's 4. Okay, so I know that I have y squared over 9, that's 3 squared, minus x squared over b squared equals 1. And c squared equals a squared plus b squared. So 16, that's 4 squared, equals 3 squared plus b squared. Solving for b squared, I get 7. Now I can write out my equation. Y squared over 9 minus x squared over 7 equals 1.